Okay, so this chapter is about electricity. It's the last chapter that we have to cover, and it is a really, really important one. You'll have noticed in the two pre's that you've done that it came up in both pre's. So we're going to take our time going through this because we have plenty of time to cover it. If you want to pause the video at any time to write down notes, I'll also prompt you to pause the video to take down the notes, and you can re-watch the video anytime you like as well. So your title is Electricity. So the learning outcomes, so what you need to know from today's lesson, you need to be able to name the two types of electricity. You might already know them, maybe you don't. And you need to be able to explain the difference between these two types of electricity. You also need to understand what an electric circuit is, and you'll be so used to this after a day or two of doing electricity, what an electric circuit is. Then probably the most important learning outcome is you need to understand what is meant by current, potential difference, and resistance. So those three things are used again and again in this chapter. So you'll need to be able to define them. You'll need to be able to give the units for each of them, and you'll need to be able to say the instrument that is used to measure them. Later on, we'll talk about how we actually calculate them. So for today, you need to be able to define them, give the units for them, and name the instrument for those three things. Okay, so let's get started. Types of electricity. So the first type of electricity, which we won't spend much time on, is static electricity. And you've probably come across static electricity before. You get an electric shock off a trolley or off a car door. That's static electricity. So what exactly is it? It's just electrical charge that has gathered in one place and can't move. And it only is able to move when you touch off it. So that's what the electrical shock is when you touch off the car door or a trampoline or the front of a television. It's electricity that is gathered up in one place. It doesn't move. And it gathers on objects that don't allow electricity to flow through them. Okay, things that are bad conductors. We call these insulators. They don't allow electricity to flow through. So for example, on the top of a trampoline, that is plastic. So that's why electricity gathers on the top of a trampoline, because it doesn't let the electricity flow through the plastic. With a trolley, if you touch a shopping trolley, that happens because of the rubber wheels on the bottom of the trolley. They don't allow the electricity to flow through them, so electricity gathers all over the trolley. And the reason that it happens on a car door is again due to the rubber wheels of the car. The electricity has no place to go, so it gathers all around the car. Okay, so that's all we're going to talk about for static electricity. The second type of electricity then that we're going to go into a huge amount of detail is called current electricity. And current electricity is the electricity that we use in everyday life. When you plug anything in, when you charge your phone, when you plug in a radio or the television, that is current electricity. And that is electricity that is moving. It's moving along wires, and it's moving very, very fast, as opposed to static electricity that does not move. Current electricity moves along wires. And the substances that allow electricity to move through them are called conductors. Okay, so the substances that do not allow electricity to move through them are insulators, and the substances that do allow electricity to move through them are called conductors. An example of a conductor is your copper wires. All your wires are made out of copper that allows electricity to flow through them really, really fast. So if you need to pause the video now to take down any of those notes, do so. Okay, an electrical circuit. So you'll see a diagram over here of an electrical circuit, and it is in the shape of a square or a circle, meaning it doesn't just go from one end to another. It goes around in a circle. And a simple electrical circuit contains wires, a battery, a switch, like a light switch or the switch on the wall for a plug, and some kind of device, such as a lamp or your television, anything at all that needs electricity to flow through it in order for it to work. So this is a simple electrical circuit here. Okay, so what is it? Basically, it's the path that electricity flows along. Okay, so electricity flows in this direction. Now, there's a reason I'm saying it flows in this direction and not the other direction. So electricity or electrical current or current electricity basically is tiny little electrons. Remember electrons from doing the atom. They're located outside the atom. So they're tiny little electrons moving along the wires. That's what electricity is. And remember, electrons are negatively charged. So electrons that are negatively charged exit out of the battery here. They go along the wire, and the reason they're going in this direction is because they're attracted to that positive terminal. So the negative electrons want to go to the positive terminal. They're attracted to the positive terminal. They will not go in the other direction because they're not attracted to the negative terminal because they're negative themselves. Opposites attract. Okay, so that's written here now. In current electricity, the electrical charge that moves is made up of electrons. They're negatively charged, and that's what an electrical circuit is. It's the path that electrons move. And there we go, that's what an electrical circuit contains. So take a moment now to take down those notes if you want to pause the video, and I would draw this simple circuit here. So we're going to keep on going with the electrical circuit. This is just explaining again the direction of the flow of the electrons. They are going towards the positive terminal. So in an electric circuit, the battery is the source of where the electrons come from. So when you insert a battery, the electrons exit out here and they flow to whatever your device needs, maybe your phone when it's charging, and they just keep on flowing around and around. That's what electricity is. So your negative electrons are attracted to the positive terminal. The terminal is another name for the end of the battery. And that's exactly what I was saying there, if you want to pause it to take down those notes. Moving on then to our three different terms that you need to know for today. First one is the current. Now, the current is the amount of electrons flowing through an electrical circuit. There can be different amounts of electrons flowing through a circuit. So that's what the current is. If there's loads and loads of electrons flowing through the circuit, the current is high. And if there's very little electrons flowing through the circuit, the current is low. So there you go, that's your definition of a current. It is the movement of electrons in an electrical circuit. Now that should say called. You're used to me making mistakes by now with my spelling. And the unit for current is the ampere, often shortened to the amp. So as I just said, there are different circuits with different amounts of electrons. The ampere, and this is often shortened to the amp. And if you give an answer saying 1 amp, you can say 1 capital A. But we'll go into that in a lot more detail in the coming days. But just know what the unit is. And it is measured using an instrument like this over here called an ammeter. So there's your definition, your unit, and your instrument. They're the three things you need to know for current for today. So pause it again there if you need to take down those notes. Next, potential difference. Now, what is that? In other words, it is the voltage. So sometimes a book will call it the voltage, other times they'll call it potential difference. They could ask in an exam, what is potential difference? What is another name for potential difference? It is the voltage. And the voltage is the ability of the electrons to move in current. It basically means how powerful is the battery. Does the battery give the electrons a big push or a very small push? So if you look at any little battery, say in a remote control or in a battery powered radio, you will see that they say a value something V. Like really small batteries might say 1.5 V. So they would give a small push to the electrons. Whereas those big fat batteries might say 6 or 9 V. So they would give a big push to the electrons to go around the electrical circuit. So the voltage or the potential difference is just the ability of the electrons to flow through the circuit. Okay, can they flow fast or are they flowing slowly? And that's to do with the battery. And you'll see there the units is called the volts. And you can, if you're writing a value such as 9, you might say 9V or 9 volts. And then this instrument is called a voltmeter. So there's your three things again. Your definition, the ability of the electrons to move from the negative to the positive terminal, the unit, and the instrument. So pause it there to take down those notes. Take your time. Is the resistance within an electrical circuit. So the resistance, like it sounds like to resist, and that's exactly what it is. When the electrons are flowing through the circuit, they can be slowed down by the opposing forces of the copper wire. So the electrons need to squeeze through that copper wire, and sometimes they can be slowed down depending on the material. Copper doesn't slow them down very much, but other materials would slow them down. So the resistance is how much these electrons are slowed down from going from A to B. All right, and an example is in a light bulb. There's huge resistance in a light bulb. The electrons can't go very fast through the light bulb. So if something has high resistance, it means the electrons flow slowly through it. And if something has low resistance, like a copper wire, it means the electrons can flow very fast. And then our unit for resistance, meaning measuring how much they're slowed down, is called the ohm. And it's that little symbol there. And if you can't draw that, don't worry about it. You can always just write ohm. And the instrument then is called the ohm meter. So again, you have your definition, you have your unit, and you have your instrument for resistance. So pause this to take down these notes, re-watch the video if you're unsure, and your homework will be up on OneNote. Okay, so I'll put up more notes again in the coming days. Thanks, guys. Oh, sorry, just to recap, just to double check, have we learned everything that we need to learn? And we have. We've done our two types of electricity, static electricity and current electricity. Explain the difference between them. Can you? Can you explain what an electrical circuit is? What does it contain? And do you understand what is meant by current, potential difference, and resistance? Thanks, guys.